Greetings and welcome to a series of videos on thermal engineering. Thermal engineering is a sub-discipline of mechanical engineering that deals with the movement of the heat and heat transfer. The study of thermal engineering focuses on energy transformation. It deals with applied thermodynamics and conversion of heat into various energies, including mechanical, chemical, and electrical energy. There are some prerequisites to understand the subject of thermal engineering. The students should have the knowledge of physics and chemistry, and of course the knowledge of basic thermodynamics is very much essential for thermal engineering. In this series, we will not focus on all the topics under thermal engineering, but we will focus on some selected topics like boiler. So we will discuss about different types of boiler, their uses and applications we will discuss. A boiler produces steam, produces high pressure, high temperature steam. This high pressure, high temperature steam is used to run a turbine, and the steam is generally expanded with the help of a steam nozzle. So we will discuss steam turbine as well as steam nozzle. And steam turbine is used to generate electricity with the help of a generator. The exhaust of a steam turbine is low pressure, low temperature steam. This low pressure, low temperature steam is again converted into water with the help of a condenser. So we'll discuss the condenser. A condenser needs some cooling water, and that cooling water generally comes from a cooling tower, and it may also comes from the natural water sources. The condensate, that means the steam that is converted into water, is again used as boiler feed water. So there will be also some discussions on the feed water treatment. To produce steam from water in a boiler, we need some heat sources. The heat is generally received by burning some fuels. So by burning fuels, that will produce some bottom ash as well as some fly ash. So those ash has to be handled, and that aspect will be covered under this series. The burning of the fuel needs some oxygen, and that is received from the atmosphere. So the supply of enough air to the furnace of the boiler is essential, and that comes under the topic of draught. That will be discussed a little bit. And above and all this, we'll also discuss a little bit about nuclear power plant, different types of nuclear power plant, the components, those will be discussed in these videos. And of course, the three modes of heat transfer, conduction, convection, and radiation will be discussed. Steam generator or steam boiler. So steam generator is a device to generate steam from water. Let us consider the formation of steam at atmospheric pressure. If we heat some water in an open container, the water vapor will start forming, and the vapor will escape to the atmosphere. Steam at atmospheric pressure cannot be used for many engineering applications. But if we entrap the steam inside a closed space, the pressure as well as temperature of the steam will increase. Suppose we entrap the steam within some enclosure. Now the pressure of the steam will start increasing. Such high pressure steam can be used for doing some mechanical work if it is allowed to expand within a proper device. And for that we need a boiler or steam generator. The steam generated can be allowed to flow to a steam engine or steam turbine. So the steam will go to the steam turbine. So A boiler can be redefined like this. It is a container and a device to add heat. And heat is obtained generally by burning some fuels in the furnace. Let us redefine the boiler like this. A boiler or steam generator is a closed vessel in which a liquid is heated to generate steam or vapor of that liquid. The vapor or steam is then exited from the vessel for different uses and purposes. So the steam will go to the specific site where it will be used for different purposes. It may be to run the steam engine or to run a steam turbine. Let us recall the formation of steam at different pressures from this TS diagram. As we know, steam is formed at a particular saturation temperature and pressure. This is the liquid line and this is dry steam line, and in between this is the wet steam, that is the mixture of water vapor and the water particles. The steam may be wet steam, dry steam or superheated steam. This first line represents the formation of steam at atmospheric pressure. But if we increase the pressure of the steam by enclosing the boiler, that means by enclosing the steam in a closed vessel, then the pressure of the steam will be more than atmospheric pressure. So if we increase the pressure, the steam formation takes place like this, and first it will produce wet steam, then it will produce the dry steam if we increase the amount of heat supplied to the steam, and also it can produce the superheated steam. Similarly, if we go on increasing the pressure of the steam, then the steam pressure will increase and ultimately it will reach a critical pressure, and that is called a critical pressure, and the corresponding temperature is called critical temperature. If pressure increases, the saturation temperature also increases and the latent heat of vaporization decreases. A boiler works at different pressures and it works at above the atmospheric pressure. If the steam absorbs more heat, the steam will be dry, and if the heat is increased even more, then it will produce superheated steam. So a boiler works in this region, then that will be called a wet steam, and if it works in this region, then it will be called a dry steam, and if works in this region, the steam will be called superheated steam. And also the pressure of the steam produced may be different. So we can represent this like this. A boiler may produce wet steam, it can produce dry steam, and it may also produce the superheated steam. So depending upon that, there will be different types of boiler, like high pressure boiler, low pressure boiler, boiler producing wet steam, boiler producing dry steam, and superheated steam. Let us understand the basics of very simple boiler. So a boiler has a space for water and also for the steam. The furnace may be located below the water space for transfer of heat for steam formation. And the steam has to be enclosed, and the produced steam will be taken away from the boiler to the required places. So we can also represent it like this. So this is a boiler in which the fuel will be burned in this region, and this may be the space for the water, and this is for the steam. The upper part of the boiler will be the space for the steam, and these two are separated by a surface in which the heat transfer takes place from the furnace to the water. So if we put the wire below the water space or in this furnace, then steam will be produced, and this steam may be taken away from the boiler at the required pressure to be used either in steam engine or steam turbine or whatever purpose it may be. So these are the basics of a boiler, very basic of a boiler. Then please watch the next videos on description on position of different parts of a simple boiler. We need a heat that is derived by burning a fuel inside a furnace, and this heat is transferred to the water, and the water will form the steam, and that steam is taken to the turbine or steam engine.